This video is part 1 of GTViewer's dynamic graphic functionality. Dynamic graphics is a visualization tool for creating an alternate view of your data based on your feature attribute values and a set of rules. Dynamic graphics is broken into two distinct types: dynamic labels and dynamic highlights. In this video, we'll cover dynamic labels. The easiest way to explain dynamic labels is to simply give a demonstration. We're looking at the demo data here, and I'm going to zoom in to find a primary conductor. And if we get a little closer here, we'll see there's a label placed alongside this primary conductor. And this label has information like the phases, the circuit ID, the number of neutrals, and the neutral type. If I pan down the conductor, that label goes off screen because it was statically placed in the GIS. If we go far enough, we'll find another label, but if we're in an area where you don't have one, the only way to find out that information is to review the feature and get the information out of the attributes, or to use a tooltip, which may or may not provide all the information you want. So a dynamic label can provide you several things that the static labels can't. First of all, let's scroll back up here to find one. This may not be the information you want in your view. You may not care about the neutral, or you may want other information. Also, as we pan that off the screen, you may want to see that label all the time, and dynamic labels can dynamically place that graphics as you're changing your view. Also, if you were using the attribute info or the tooltip, that label that you see there isn't going to print if you printed this map. So another advantage of using dynamic labels is that they're printable. So let's see what the difference is using a dynamic label for this same type of information. I'm going to scroll back up here to where the label is, and I'm going to turn it off. Now, I've already got the display manager up, and I'm going to find primary conductor text and turn it off. Now, if we scroll around our data now, there's no primary conductor labels. So the next thing is I'm going to turn on one of our dynamic graphic actions. And we'll go over how to set it up and use it later on, but I just want to show what it's doing. Now, I turned it on here, and you'll see there's a label here now that wasn't here before. And it's got the circuit ID, the phases, and the voltage. Now, as I pan down the view, you'll notice that this label, it doesn't stay in it stays in the same spot until you go outside the view, and then it moves. So it's always in the view, even if we're going in a different direction. And it's oriented based on the primary conductor. Now, if we got to a different phase or voltage, I think if we go far enough over here, it will get there. You'll see here's two different ones at the same time. Two different circuits. If we zoom out, they get a little larger, easier to see. You also have the ability to say whether or not they gray out when you turn on emphasize mode. In this case, they don't, so they're even easier to see. And the information is specified here when we define the dynamic label, and we'll go through that in the next sections. So how do you set up dynamic labels? GTViewer has the dynamic graphics functionality built into the product, but setting them up uses an add-on app that's delivered with the product, and you use that application to configure it. Now, once it's configured, any GTViewer seat can use it and turn it on and off, but to set it up, you have to use this add-on app, and it's just called the dynamic graphics interface or dynamic graphics. There's a couple of different versions. The newer one's .NET version. There's an older one that's not .NET, and it's typically under applications, and I'm going to start it, and it brings up a dialog like this. Now the demo data has several provided with it just to illustrate some of the functionality. One of them was the one we were using in the previous demo, which shows the primary conductor label. Now there's two different ones. There's an up close and a far out one, and there's two different ones because they do two different things. One is geared for viewing up close, and one is geared for viewing farther out. So this one is turned on at the moment. It's active. It's got a min and max threshold zoom level that it's going to display. It's based on a feature in the primary category, and it's the primary conductor line. And you can have a criteria, which is whether or not it's going to show a label. That could be used, and it's a very powerful tool that can say whether or not you want to display. Let's say you're drawing a label for poles and you only wanted to show labels that were of a certain height or a greater than a certain height. It's something of that as a criteria. It's whether or not it's used or not for that feature. Then the next item here is the type. We are labeling a line. Since the primary conductor is a linear feature, it's going to use a linear or line label type. There's several different ones. There's point label, there's line label, polygon label, and there's also highlight and simple highlight, and those are the two dynamic highlighting items. We're just going to focus on the labeling in this video. Now, the next part here is the label properties. You can tell it the color. You can tell if it's offset from the point that it's using. Then you can tell it the label, and there's a little 3-dot button here to expand that. And this is an expression that's going to tell it what to use for that label. And if we look at this, it's the table dot attribute name, and they're always in square brackets, and that means it's going to show CCT is the circuit ID or the circuit, and it's in the connectivity table. Then it's going to do a slash, and then it's going to show the phase, which is also from the connectivity table. And then it's got CRLF, carriage return line feed. That goes to the next line, and it's going to show the voltage, which comes from the primary conductor table. Now, setting up these expressions may look complicated, but it's actually pretty simple, and it does kind of help you here with showing you what attributes are available in the different tables. And all of the expressions in GTViewer work the same, so if you learn how to use them, you'll know how to use them for several different things. And maybe that'll even be another video, but it's basically just simple arithmetic or adding strings together, or it could be complicated and it can be simple. This one's a pretty simple one. And let's go back here, and you can choose the font, the size. There's several ways to specify the size. There's a width limit. It means that it has to be, the text you're placing has to be narrower than the line you're placing it on. And there's a few different options there. One is it has to be less than the segment that you're on, and one is that it will scale that text automatically to fit. Or you can have none at all, and it'll just place it in a fixed spot. You can tell it how it's justified. You can fix its size, or you can make it the same size at any zoom level. Removing collisions, whether or not you have your dynamic graphics overlapping with itself, you can remove those. If there's a duplicate on the screen, like if we're moving down a circuit or a primary conductor, and there's multiple labels for the same circuit because it's really long or has multiple segments, then you really just need one of those to be on the screen, and that will remove those. You can tell it whether or not the dynamic label is only for visible items, or it can be for stuff that's not visible, as long as you uncheck that. And finally, you can mask it so it'll cover up what's behind it. And if your label's partially out of the view, like hanging off the side of the screen, you can remove those as well. And the last thing here is clipping. by default, if clipping is off, it's going to center the label for the entire feature. Now that feature may or may not be on the screen. If you turn clipping on, it will clip the feature to the screen first and then compute where to put it. That way it will always be on the screen. And that's usually what you want to do, but there are cases where that may not be needed. And that is all of the features that you have for dynamic labels. And I'm going to illustrate these a little bit more as we go through it. Okay, so let's go through the options here using an actual example. And we'll use the primary conductor labels that we've been looking at so far. So I'm going to zoom in and get a good view of some primary conductors here. These are our dynamic labels here, and you can tell they're different. There's this one's the circuit C and this one's circuit A. And if we look at our zoom level down here at the bottom on the status bar, we're currently at 447. Well, this dynamic label is used from the minimum threshold is 0, which means there's not a minimum, and the maximum threshold is zoom level of 900. So if we zoom out past 900, they shut off automatically. And if we zoom in just a little bit, we'll get them back. I'll scoot back over here where we were. And we can change this how we want. I can change it up to, let's say 2000. And then we can zoom out quite a ways. See, I'm at 2500 there. And they shut off at 2000. We'll get back just a little bit. We're still at 2200. And there we go. The problem when you zoom out too much is that they'll start to get cluttered if you don't use a smaller font or use some of the other options. We can look at some of those options too, like you'll see these two here are conflicting with each other, and there's also a duplicate. So there's options for that. I can remove the collisions. These would be collisions here. You'll see it got rid of one, the range of one was overlapping the range of the other. Now you don't get to pick which one it's going to show, and if we zoomed in here, they would both come back on because they're no longer colliding with one another. Something else here is these two are duplicates, so they're just different labels on more segments of the same feature, or two separate line segments. We can look here and see the line segment goes right there where the highlighted is to this transformer, and then this is another one. So there's actually two different features here. They're each getting a label, but the label is the same. Now I can tell it to remove the duplicates, and it won't put the same label twice. Now let me scoot over just a little here. This one here is an A, this one's a C, so they're different. Now if we zoom in, it'll switch around and move to put the label where it needs to be seen. It's just that it won't put multiple labels of the same thing. That can be a problem if all your labels are the same, but it's an option, so you don't have to use it. I think in general, though, with linear elements like this, and your labels are showing something different, then you probably want to use the remove duplicates. And you probably always want to use remove collisions unless you really need to see all of them that are there. Let's look at, let's scoot over where we can see this a little better. And let's look at some of the other options. Our criteria we've discussed earlier, where this is an expression, it must be true for the feature to be processed. So let's say you only wanted to show labels on three-phase circuits. You could put that as a criteria, or you only want a particular circuit, or something to that effect. It can be set to only process features that meet this criteria. The type, there's several different types of labels. We're putting our label on a linear element, so we need to use a line label. If you use a point label, that can be used to replace symbols, or it can be used to put text on a symbol. And you've got polygon labels, which will put the label in the center of the polygon. But we're going to leave it as line label now. Color is pretty obvious. It's the color of the text. Offset will shift the text in one direction or the other, X and a Y. They all have to be the same, but you can use it to shift it off to the side so it doesn't cover up the feature or something to that effect. Now, instead of using the offset in my example here, I've used justification, which justifies the 2 lines of text. And we can change that just to show. If I change it to upper left, see it moves down. It's the upper left of the text is what it's going to, the point it's computed to place it on the linear feature. Let's put it back at center. Fixed size, we're currently using fixed size. It doesn't matter what our zoom level is. That text is always the same size. If I zoom in really close, it's still the same size. You can tell it not to do that. I can uncheck the fixed size, and now it's zoom dependent. So if I zoom out, it's going to get smaller. If I zoom in, it's going to get larger. Usually it works better for fixed size, but that's really dependent on what you're trying to show. And let's see, we haven't shown the mask. The mask just kind of blots out what's behind it and draws a little box behind it. That may or may not be useful to you, but it is an option. It makes it a little easier to see them, but it does cover up what's underneath them. That's kind of what the mask is for. Visible only, you can show labels on features that aren't visible, but if we turned off our primary conductor, let's show that. If we turn it off, let's find it here, primary conductor line, your dynamic label goes away too. So if I turn it back on, and let's say visible only, it turned it off and apply it. Now if I turn my primary conductor line back off now, the text remains, but the feature goes away. This could possibly be more useful with the dynamic highlighting, because it works the same way, and except it leaves behind the highlight of the feature, and it could be styled differently. So let's turn that back on. Removing partials. This is a little difficult to show, but it basically says that, let's turn off a few things and see if I can get one to show. Okay, here we go. This isn't a very useful example, but see how the text is partially out of the view? If we turn on remove partials, it won't show that because it's slightly out of the view. It's partially in the view. So if I get it where it's all the way in the view, it comes back. I think it probably is a good idea to leave that on, but it's up to whatever you're trying to show. There's a couple of other options here that are more complicated. The width limit. This is saying if your text is larger than or wider than your segment, not to show it, or it's only going to show it if it's less than the width of the segment. You can also say that it has to be less than the width of the whole line, not just the segment. Or you can use auto scale in certain situations, but there's some more parameters you have to set. And some people don't like that because you've got various texts of various sizes for the same thing. Or you can say none at all, and it won't limit the text, and it'll always show it no matter what size the line segment is. But let's leave that on less than line. The other item here is clipping. Clipping is a little difficult to show as well. Let's see if I can get one to show. I'm going to turn clipping off. And clipping is saying that, well, when it's on, which it is now, I've turned it off on the checkbox, but when it's on, it's only using the parts of the line that is in the view. Now these actual primary conductors go somewhat outside the view to the right, and that part could be quite a bit, and if it's going to the center of the line, that center point is going to be off the view. And even though it's drawing a dynamic graphic, it's not going to be in the view. So if I turn my clipping off, you'll see that this second, or the bottom line here of the conductor, it's not showing a label anymore because the center of this line is over here, or off to the right somewhere. But when I clip it, you know, it comes back. Let's make sure that was not just the collision here. I believe, yeah, remove collisions and remove duplicates is off. So when the clipping is on, it shifted both of these. It shifted since they're both based on this, what's actually in the view, and they can't override each other, or they can't, well, I guess we don't have collisions on. So it's just the computation shows both of them because it's using only what's in the view. This is more computationally intensive, but it gives you a much better result than if we had clipping off. And in general, I think you want to have clipping on. One last thing to show here is our label itself. And this may be the most important of the items there. Currently it's showing the circuit ID, the phase, it goes to a new line, carriage return line feed, and then it's showing the primary conductor voltage. Now let's change this to be something else. I'm going to copy that to my clipboard so I can get it back when we're done. And I'm just going to start with a fresh label and say, here's our primary conductor table, here's our attributes in it, and many times I need to work with fixing connectivity records, and it's often useful to be able to see all the node values for the feature that you're looking at to see where your problem may be. And you can quickly define a dynamic graphic to show what the node values are. And I'm just going to quickly do this. Let's say we got they're in the connectivity table, not the primary conductor table. And I'm going to double click, it puts it up on our expression line, and I'm going to say carriage return line feed, and then I'm going to put the second one. And apply that. And now it's showing our node values for the line, or for this feature. Now we can make that a little prettier. I'm just going to type in some text, N1, and then I'll say N2 on the second one. You don't have to use the dot 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 button to show the expanded view. It's sometimes easier, but if you're just making quick modifications, you can do it that way. Okay, so the last thing I want to show is I want to create a new dynamic graphic action from scratch and show you everything that's involved in creating one. We've only been looking at ones that already existed, and I think it's of some benefit to see one created from nothing. So I'm going to turn off our primary conductor one just so it doesn't interfere with what we're looking at, and I'll turn the graphics back on. And I think in this case I'm going to do a new label for this pole. It already has a label, but I'll show you how to replace it with something a little different. And let's turn the pole label off that's in the GIS data. So I turned the label off that existed already, and I'm going to review a pole just so we can kind of look at what's available. We've got class, height, type, and ownership. We can use any attribute that's here. But we were showing the default was class and height, and let's just make a new one that has some different attributes. So first off, over here in the dynamic graphics interface, let's say new. I'm going to give it a name, and I'll call it poll demo. You can tell it to copy the default from one of your existing actions, but I'm not going to do that because I want to create it from nothing. And this gives us a new item in our list. It's red because it's not complete or not valid. It's active. I have to give it a name. I'm going to call it poll demo, which is the same. And I'm going to give it a 2000 maximum range. And we have to pick our feature. We have to pick a category first. Polls are in structure category. I'm going to pick by feature. Let's do by feature component because we only want it to be on the poll symbol. And we'll leave the criteria as true. That means it'll do it to all. And we're going to do a point label. And I'm going to leave it red just so we'll easily see it. And let's pick our attributes. We can find our poll table in the list. And we can say class. Let's make it look a little prettier. And I'm going to do a carriage return line feed, which will go to the next line. And we'll say height. And I'm going to find the height attribute. You just double click to make it go there. I'll validate my expression and say OK. And we can probably just try it and see if it goes. Now, it shows what I typed in just fine. It's not exactly where we'd want it. We can try just changing our justification to see if that is good enough. We may have to use our custom offsets a little bit just so it's far enough. We could do let's try just a different one, see if it's any better. We can always just say, let's do -5. Let's say -7. I believe these are feet. Let's do 9 and maybe even go up a little. Now that may not work for all, but we can adjust that later if we need to. We can remove collisions. I'm just going to turn that on. We can remove duplicates. I don't think we want to remove duplicates in this case because there's nothing unique in that, and you could have several polls of the same class and height. And we don't want to mask it. Keep rotated. If your symbol is rotated, it will rotate your text to what the symbol was rotated for. This is usually if you want to replace it with another symbol and you want that symbol to be rotated. So you could replace your symbology with different symbology and it would draw it as a different symbol instead of text. Now let's zoom out and see what we've got. Now our text size is fixed. That's a little odd for our poll text. So I'm going to tell it not to be fixed. And it's a little big now, so let's see, maybe 10. Let's make it a little smaller than that. And I think that has got it. There's going to be some overlap with other features, but that's no different than how it would be with regular text from the GIS, unless it was manually placed. We can use our emphasize mode here to get a better idea. You'll notice my emphasize was off by default. I can turn that on and get rid of my locate there, or my point locate. And you'll see it's got quite a few of them here. And that's all you have to do to create a dynamic label. Now, as I said before, you can print these. You can export them to session graphics with your tools, dynamic graphics to session, and you can they'll be in your screenshots. Obviously, if you take a screenshot or a view to clipboard, and that's different than if you were using just looking at the attribute information or the a tooltip. A few things to keep in mind with dynamic labels is, as long as you're displaying, a reasonable number of them, your performance will be pretty good. And it does cache everything, or up to a point. And as long as you stay in the same area, the performance will be really good because it doesn't have to look up the database entry or database values for each one in the view. But if you start trying to do hundreds and thousands or 10,000s or hundreds of thousands of them, it's going to definitely affect your performance. And that's not really what it's meant for. It's really meant to show what you're looking at in your view. So if you can't reasonably use that information, and you're trying to do it for your whole data set, you may have some performance issues. But for this type of information here, now, like I said, my max zoom level turns off at 2000, so which is a little high for this, but it was a good example. We don't have to worry about it now because they're not being drawn. Now, if we changed it to, there was no limit, and we zoom out all the way, you can tell it's taking a little longer to update, and we can't even see them. They're so tiny. They should still be there. If we zoom into one, you can still see it there in the magnify view. But that doesn't do us any good. So you don't want to set your max to some outrageous number and it's having to do all the computations for this. Now, how many is it doing? There's a line in the dynamic graphics dialog here. It's got 129 cached, and it just drew 103 of them. Now, once it's cached, your performance is not so bad. It's just that initial time when they're not cached, and it has to go load them all from the database, the GTViewer database, and then it will store them for some time. But if you have too many, it's going to use a lot of memory, and if you don't have a lot of memory to support that, you may have some issues later on. So just keep in mind, it's not a unlimited resource, and you should try to keep your number down so that the performance stays up. So that is dynamic labeling. Now, in another video, I'll do dynamic highlighting. It's very similar, except instead of drawing text, you're going to highlight it to a different color. And what that allows you to do is set different criteria for displaying the features, or it'll just highlight on top of the existing feature, so you can make features with a certain criteria stand out. There's a couple of ways to do it. There's a simple one where every feature gets the same color, and there's a more sophisticated one where you can map the color based on one of the attributes. And you can have, such as one of the examples there is a highlight gas main by pressure, and it is highlighting. It's the more advanced highlight, and it uses a color map here, G pressure, and if we look at our map and go to G pressure, it maps high to red, medium to orange, low to blue. Whereas a simple highlight, and let's see if we have a simple highlight. Here's a simple highlight, only has one color, and everything that meets this criteria will be that one color. But we'll go more into the dynamic highlighting in another video. That concludes this video on GTViewer's dynamic graphics. I hope you learned something, and thanks for watching.